All right, so VP30, this is the one that actually took me like more than 2 weeks to solve myself. And by the way, I didn't get to the end of the original problem. It's got hard parts at the end that I didn't get to. But the idea here is that you have images from a camera, but the camera takes tiles and they have to be reassembled. So you have a set of tiles. The first set, just to practice on, is this. This is like a low resolution image in black and white with just pounds and spaces. So it's like an 8 or 8 by 8 or 10 by 10 image. And the tiles have been flipped and rotated randomly. So you have to reassemble them, and the way you assemble them is you make the edges match. So down here, there, when you get the answer, the edges will match. Yep, so here, this is dot, pound, dot, pound, and this is dot, pound, dot, pound. The right edge of this one matches the left edge of that one. The bottom of this one matches the top of the one below it, and so on. The borders match all the way around, and that's how you can tell how to line up the tiles.
Oh, okay. I got it confused. I thought the individual dots and hashes were scrambled and we had to unscramble.
Nope, it's a low resolution image. You're seeing the original pixels. And this, like I say, this took me more than 2 weeks to get this working. It's an interesting challenge. Now, I broke it up into a lot of little pieces, so you can do some fairly simple stuff to get the minimum points, but to get the most, you actually have to reassemble that big image. And that took me a while to figure out how to do it and how to do it reliably. And of course, you start with this 3 by 3 to practice on, and to get the flag, you have to solve a 12 by 12 one. So you have to get your algorithm working. I can tell you how I did it, which is not necessarily the smartest way to do it, but what I did was I turned this into a 10-bit binary number, and I recorded the number on the edge, all 4 edges, and then I realized, first I thought I would have to have a horizontal flip and a vertical flip and do them both, and then I realized, just thinking about real tiles, all that matters, you can rotate it, or you could flip it and rotate it, and that's it. There's only 8 possible positions. One side is on top or the other side is on top, and you rotate it. So yeah.
I would just imagine as a puzzle piece, each hashtag is an outer, each dot is an inner.
Yeah, just like a jigsaw puzzle of a sort. Exactly. So anyway, so that means for each.
I'd probably partially cheat and just draw that shape out and then cut it out and see which ones fit.
You could in principle do that. That would be fine. Anyway, this thing here. So that means I made for each tile, I recorded this number to identify the tile. This is a unique number, and then a list of 8 numbers, which are I chose a direction to work in. I used clockwise, so I take, this is the high order bit and low order bit, and I read this one this way, and read this one this way, and read that one that way. And then I would flip it and do it again. So I get a total of 8 possible edges for each tile. So I made a dictionary with this being the key and that list of 8 edges being the next one. And now I counted how many edges appear only once, how many edges appear only twice, how many edges appear more times. And the answer is, the edges that appear only once are on the outside. That's what this does. The stars are edges that have matches. So here's a tile, and here's the 8 numbers, and you can see there are there's one edge here. This is forward and backwards. This has no match. This is a number that does not appear on any other tile, so it must be on the outside edge. And this tile has 3 edges that match other tiles and one that doesn't, so it has to be in the center of an edge like this. It's got 1 edge that doesn't match anything and 3 edges that match neighbor tiles, so I can now tell corner tiles from other tiles. This one is this is a corner tile because there are 4 edges that match other edges, and there are 4 edges that don't match other edges. So there are 2 edges on the outside and 2 edges on the inside. So you can tell corner, and there's going to be one in the middle, and that'll be the one that doesn't have any unmatched edges at all, which will be this one. All of them have asterisks. This one has to be in the middle because all of its edges have matches in other tiles. So I got that far. I had real trouble getting the rotating working, but that's what held me back for like a week. But that's the point. So here I was able to find the corners, sides, and insides by just counting the matching edges. And then I was able to get here the corners. Then to assemble the grid, this took me a while, but I managed to write an algorithm to do it, and I made this 50 points because this is pretty hard. And the next step I didn't include from the original puzzle, which I might. What they say is now remove all the edges and keep only the inside part, join them together, and now look for sea monsters in there. There's a complicated pattern of asterisks to sea monsters, and they can be in any orientation. You have to count how many of them there are, which Might not be that hard once you've assembled the whole image, but I didn't go that far because I've been spending so long on it just getting to here. I kept getting confused. And so that's what I did. The trick with the numbers is how I chose to handle the edges. There are probably other ways to do it. And dictionaries were the most useful data structure for me. And I got snarled up until I decided to do what I should have done all along, break it up into little functions, like a function that flips a tile, a function that does rotates a tile one step, and so on. And I realized it's pretty arbitrary. This whole assembly could be rotated or flipped. So what I did to match the examples in the original problem statement was I found the first corner tile and put it in the corner without rotating it, without flipping it. That's how I got the orientation that was expected. But the orientation can be anything. You'll still find the flags. All the flags are carefully designed to be things you can find out regardless of how the overall grid is flipped or oriented, because you could match all of these and then rotate it 4 ways and flip it, and it would still match. So that's what I wanted to show you. It's a good puzzle. The first parts are easy, and at the end it gets pretty hard, which is the plan for all of these things. So I'm going to stop that recording.